Hi, this is Jacob Roden going over the Kinematics Workbench for ENGT196. This is my kind of finished student project. We have the machinist tool holder. Here we have the little plastic inserts for putting the tools into, and we got the handle and the base, which is all made out of sheet metal, and then I modeled a Cat 40 tool holder, so we have the taper and everything. I didn't put a pull stud in it or a tool in it, but you can see that it's the right size and it is fitting in there without clashing and everything. And so with kinematics we can actually see I guess an example of it getting kind of placed into the right spot. So here we have our mechanism representation. We have a prismatic joint, which is from the base to the tool. We can see the tool's axis right here, which is Z's coming out right here. With this prismatic joint, I made it so that it'll come out and get placed back in. And then with that command, I put the motor on it, which is oscillating, so that instead of it just moving all the way out and staying there, it'll move out and then back in. So with the motor open, we can press play up here, and we can see as the tool comes out, and you can see that little inside spot right there where it'll fit right in. And you can see it's not going through anything. It's just kind of sitting in that spot where it needs to be. And ideally with this angle, and as long as you're not using, some really, really large tooling, like a big rougher or a big boring bar or something, this should be able to just sit in this nicely without falling out, especially with this, with the kind of dogs in there and all that surface area. And then we can see it get placed right back in there. And to do this, what I did was I went into the equipment design toolbox or workbench, and with this you are able to open up the define kinematics. You can select, once it loads a little bit, you can select the part body, and then you can pick whatever joint. If I wanted this to rotate for whatever reason, I can pick rove loop, but I just picked prismatic. And then you could define your plane. So I just defined it as on these 3 points on this circle, and you can see that that's where our axis is. And then you can select the tool, and you can see the green arrows where it's going to be moving, and obviously that is where we want it to be moving. We don't want it moving in some other direction. And then we press yes on the command joint, and we can see the prismatic joint show up right there. And then what we would do is we would go into the mechanical systems design workbench, and then that allows us to cancel, and you go back in and deselect. Yeah, make sure you deselect the define kinematics option, and then you can right click on command, and you can attach a motor. Obviously there's constant speed, so if you want to just have it move out at a constant speed, if you want to have it move up to a certain distance over a certain amount of time, or just like what I did with oscillating. And then you can pull that motor up, and you should be able to watch it as long as this motor's not preventing it, which it looks like it is, because it's not letting it move, because we already have it as a prismatic joint. But obviously it works okay on the first one, and that is the kinematics workbench. Is very useful for adding movement, making sure that when something's moving, it's not going to hit something. So maybe you had some kind of linkage assembly that you wanted to move. Maybe you're having it rotate, or you're making it move up and down or something. You want to make sure that there's no clashing and that everything's kind of attached and connected smoothly. You could do that and watch as everything moves. Or obviously for this, you can just show an example of the fact that your tool holder holds tools and everything. It's very useful, very nice for showing off projects and kind of giving a good display of what you're doing. Thank you for watching. Have a great day.